Hello and welcome back to Class GIS Class Spring 2020. Miss seeing you guys in person. I sent you an email with details of what we're going to do today. We're assuming we're millionaires looking for property in the Clark Fork watershed. We're looking to build a cabin based on a set of 5 different criteria. We're looking for a location that has a slope of less than 8 degrees, that has a southern exposure, that has a view of Tweedy Mountain, which is the highest peak in the area, that is within 1 mile of a river, and that includes more than 10 acres. So if you guys are following along today, you can bring into your map, open a new instance of ArcMap and bring into your map the files I sent you: Clark Fork Watershed, the Mosaic DEM, Tweedy Mountain, and US rivers. I'm going to put Tweedy Mountain up here. Tweedy Mountain is kind of hard to see because it's outside of the watershed, so I'll make it big. It's down here, just outside of the watershed. The Mosaic DEM, I did a little of the work for you already. I pulled all the 30-meter DEMs that cover the Clark Fork watershed and mosaic them for you, but you guys already know how to do this, so you know where to get these DEMs. Here we've got the US rivers. This is a file you're familiar with. And this is the Clark Fork watershed, all the water that drains from this area into the Clark Fork of the Columbia River. It's truncated a little bit here and here at the Montana state borders, but this is the Montana portion of the Clark Fork watershed. I'm going to make that visible for you and blow that up to size 2 red so you can see it on the map, hopefully. This is the data that we're starting with, all the information we can download online. And we're going to use those 5 pieces of information that we're looking for to try and locate the ideal place to put our cabin. So the first thing we want to do is look at that slope. We want a slope of less than 8 degrees, relatively flat land for building our cabin. So if you have not already done so and you're trying to follow along, make sure your Spatial Analyst extension is turned on. Go to Customize Extensions and make sure that Spatial Analyst extension is turned on. So if it is, we'll go into Arc Toolbox, scroll down to Spatial Analyst Tools, expand that, expand Surface, and look for Slope. We want to calculate the slope. Go ahead and open that up. Put the input raster in as the Mosaic DEM. Now actually, I'm going to backtrack a little bit here. I'm going to stop this and close out this slope. I'm going to set my geoprocessing extents because this is going to be a big process running the slope on this large of an area. So I want to try and limit this to the extent that's possible. Instead of processing the entire Mosaic DEM, I'm only interested in the Clark Fork watershed. So I'm going to set my processing extent to the Clark Fork watershed. I showed you how to set your geoprocessing environments here, geoprocessing environments. I showed you how to set your workspace. I've got mine set to the Clark Fork Cabin geodatabase. But what I'm interested in doing is setting my processing extent. I want to change that to be the Clark Fork watershed. What that's going to do is take the square area of the Clark Fork watershed and limit my processes and all the tools that I run to that extent. It's not going to expand past that. So that should speed this up a little bit. Let's set that processing extent to the same as the Clark Fork watershed. And just for giggles, let's set the output coordinates too. I want to set this to, I can either say as specified below, UTM zone 12 north, and actually give it a coordinate system. In this case, let's stick with UTM zone 12 north. Or if you want to go in and look at the coordinate systems assigned to each of your files, you can tell it which one you're interested in using. What this is going to do is each time we want to run a process, instead of outputting the data in whatever coordinate system it started in, it's going to go ahead and do the projection while it's making that analysis and put it in UTM zone 12 north as the output. So you can choose one of the 4 files we have in here. If you pick Mosaic DEM, it's going to be in UTM 12 north. So let's just stick with UTM 12 north, and let's say we want everything to be processed to the extent of the Clark Fork watershed. We want our output data to be in UTM 12 north. So we set that through the environmental settings. Okay, you can close that out, and let's go back in and open that slope back up. So again, that's our toolbox, Spatial Analyst Tools, Surface, Slope. So let's put the input raster in as mosaic DEM. It's going into the geodatabase I specified. So I'm going to say, let's call this slope less 8, because I'm looking for less than 8 degrees slope. Output measurement degree, planar, all of this is fine. We can leave all of that set to the default. If you have your help open, it will explain to you over here on the side what the degree means versus percent rise, what the methods are. You shouldn't be familiar with planar versus geodesic. And the Z factor we can set as 1 because in this case, if you look at the mosaic DEM, our altitudes are in meters and UTM zone 12 north is also in meters in the XY direction. So we don't need this time to change our Z factor. So let's go ahead and say okay and run that slope. Now, if you're doing this and you're not seeing this little slope running down here and you're wondering if your computer is actually processing this, slope is a big calculation. It's running through quite a few 30-meter pixels in here to do this calculation, and it's going to take a little while. If you're worried that it's not doing the calculation for you, you can always go up to Geoprocessing, Results, and open that menu up. Under the current session here, if you expand that, see this little icon looks like a, oh, it just popped out, but little icon that looked like an hourglass was showing, and that meant it was still completing the tool. It was still running that result. Once it completed, it gave me the little tool icon, the little hammer that says it finished. So I'll close that back out. But you can see the slope came up, and it is only processed to the extent of the rectangle bounding the Clark Fork watershed. So we cut out all this extraneous data in the mosaic DEM that we're not interested in. We don't need to use that data, so we don't need to slow this down any further by processing data we're not interested in. So I misnamed this. I called this slope less 8 because what I'm interested in is the slope of 8% or less, but what this actually calculated was the slope of the entire DEM. You'll see the greatest slope is 82 and the lowest slope is 0. What I want to do is take this raster that calculated the slope for me, and I'm going to change that name, call that just plain slope, because I was jumping ahead a little bit. So I want to take this slope and use the raster calculator to split that down to above and below 8 degrees, because what I want to do is throw away that's anything above 8 degrees and keep anything that's 0 to 8 degrees. So my next step is to open that raster calculator and split this data set. The raster calculator is a really powerful tool that allows you to do all sorts of mathematical calculations on your data. It's great for processing rasters like this, where you have continuous data throughout and you want to split that data into something that means a little more to what you're trying to get towards. So the raster calculator can be found under Spatial Analyst Tools in our toolbox, under Map Algebra. Expand that, and the only tool you'll see in there is the raster calculator. So go ahead and open up raster calculator, and we're going to write an equation here similar to the way we did with select by attributes. Double click on slope to make that show up as your first comment in your equation. Use the less than key, and we want to say less than 8. So it should read slope less than 8. That's all we're looking for right now. It's going to split this into 2 different categories, above and below 8 degrees. So it's going into my Clark Fork Cabin geodatabase. Let's name this slope 8 less, just so that I'm using a different name from the last one. I went into my geodatabase and renamed that back to slope so it would overwrite, but if you didn't change the name in your geodatabase, it's not going to let you overwrite that. So we've got that name, say okay, we're all set. That should process again to the extent of the Clark Fork watershed, but it's going to process the slope and get rid of everything that's above and below 8%, split it into 2 categories. Instead of a continuous 1 to 82 or 0 to 82 here, it's going to be 1 to 8 and 8.0001 to 82. Notice my raster calculator is running down here. I'm going to go ahead and open up that results menu. Hopefully you guys can see this. The two tools that I have run are showing up here with the tool icon, but the little hourglass logo is where I'm running the raster calculator right now. As soon as that finishes, that's going to turn into that hammer saying that that's done. So now what this has done is split my slope into black or 0, where it does not meet the criteria of less than 8, and 1, where it does meet the criteria of less than 8. So what I want to do in this instance, I'm done with the slope. I'm going to collapse that and uncheck it so it's not showing on my map. And I'm not interested in seeing these areas where the slope does not meet my criteria. So I'm going to make that hollow and get rid of that altogether. I'm making that disappear by setting the outline color to null and the fill color to null. So all I've got showing up right now, the areas in green, are the areas that match my criteria of being less than 8 degrees slope. So we answered the first question. The second question is looking for a southern exposure. So we need to determine what the aspect is from this DEM. Go back into Arc Toolbox. We're going to leave raster calculator expanded because we're going to come back to that a few times today. Go back into surface, and this time instead of going to slope, we want to go to aspect. Again, we're going to calculate the aspect of the entire raster, but then we'll use raster calculator to split that out as to whether it's a south-facing slope or anything else. So open up aspect tool. Our input raster is again the mosaic DEM. We can leave everything else the same. I'm just going to name this aspect. You can leave the method planar and say okay, and let that run. That is again going to give us a continuous raster, everything from 0 to 360 degrees aspect, everywhere within the processing extent of the Clark Fork watershed. So what we're looking for is a southern facing aspect. We want to set our aspect between 155 and 205 degrees. So once we have that continuous aspect, we can again split that out like we did with the slope to anything that meets the criteria of greater than 155 or less than 205, which is an approximate south-facing aspect. So as soon as that's done processing the slope, we'll open up raster calculator again and run that calculation. Okay, so there's the aspect. They like to give us these colorful rasters when we're processing. So as you can see here, if we look at what the aspect has been categorized into, 112.5 all the way up to 247.5 qualifies as southeast to southwest. But let's just stick to 155 to 205 and we'll call that approximately south. So we're going to go back into Arc Toolbox, open up that raster calculator again. That's under Spatial Analyst Tools, expand Map Algebra, raster calculator. This time we need to make this a query that is above and below. So we need to use the parenthesis. So open parenthesis, double click aspect, greater than 155, close parenthesis. Use the little ampersand signal here that says and, open parenthesis, double click aspect, greater than, or I'm sorry, less than, backspace, not greater than, less than 205, 205, close parenthesis. So this should read open parenthesis, aspect greater than 155, ampersand, or I'm sorry, close parenthesis, ampersand, open parenthesis, aspect less than 205, close parenthesis. So we just need to give that a place that that's going. We'll call that south, because that's what we're looking at, and say okay. That is going to once again get rid of this continuous raster from 0 to 360 degrees and give us a raster that is 0 or 1 based on whether or not it meets our criteria. I'm going to go ahead and uncheck this aspect because we're done with that. Collapse it and get it out of the way. I'm going to do the same thing. As soon as the aspect comes in that's above and below, it's going to be ones and zeros again. 0 meaning it did not meet the criteria. I'm going to get rid of that so that I'm only seeing that in the color, let's do red. Actually, the outline boundary is red, isn't it? So let's do the color yellow. All right, so I'm going to nullify my zeros and make my fill bright yellow where it does meet the criteria. So now the places where the yellow and the green overlap are the areas that meet those two criteria. They have a south-facing aspect and they have a slope of less than 8 degrees. Now let's look at whether or not we have that view of Tweedy Mountain. There's a tool in Spatial Analyst called watershed, also under Surface. So our toolbox Spatial Analyst Surface, we want watershed that tells us whether or not, based on this DEM, where we are has a view of a certain feature. Tweedy Mountain is the feature that we're interested in here. So let's open that tool, watershed. Tell it the input raster is again the mosaic DEM. The input point or polyline observer features, we're using a point, is Tweedy Mountain. And we just want to say view is the name, because all we're interested in is whether or not this has a view of Tweedy Mountain. You can leave everything else the same, set to the default, and say OK. This is going to process through and once again tell us 0 or 1, whether it meets our criteria. 1 or 0 does not meet the criteria. We can again color that to determine whether or not those areas of color overlap. Anywhere that we're lacking color and can see the DEM does not meet those criteria. So now we have 3 different criteria that must overlap in order to be qualified for our Clark Fork watershed cabin. So just waiting for this watershed to process. Okay, there we go. We've got visible and not visible. So let's set visible to a bright blue, we can see it, and not visible to a null color. Now we have areas of overlap, and don't worry that it doesn't look like there's anything visible. Oh, here it is. You can see a little better in blue. There are not very many areas showing up in blue, but we will get, when we get to the end, we will figure out whether or not it meets all 5 of our criteria. But right now what we've got is areas in green that meet the slope criteria, areas in yellow that meet the southern exposure criteria, and areas in blue that meet the watershed criteria, or whether or not they have a view of Tweedy Mountain. So we've worked this down to 3 different criteria. The next one is whether or not it's within 1 mile of the river. So what we want to do here is create a buffer around the rivers. Now remember, the rivers cover the entire United States. So if we're going to create a buffer here around the entire US, it's going to take a little while to do that. Instead, we've set our processing extent, and this is another time-saving measure, to only process within the Clark Fork watershed, even though we have the entire United States. So you should know where your buffer tool is. Let's scroll back up and go into Analysis Tools under Arc Toolbox, expand Proximity, and here we have the Buffer tool. So our input features are US rivers. Keep the name US Rivers Buffer. We want to set this to 1 linear mile. So our distance is 1 linear mile. We can set up everything else the same, but remember, we want to dissolve this because we don't want to have all those little lines running through here. We're just going to dissolve by everything in this case, because we want one continuous area that's within a mile of all of these rivers. Everything else can stay the same, side type, round, planar, etc. We can leave that to default, but we do want to dissolve everything in this case. So you can run that dissolve tool. It should run pretty quickly. Here it comes. So now we've got a dissolve around all of the rivers within that area. So what we're looking for is any of these criteria, the view, the south facing, and the low slope areas that happen to fall within 1 mile of the rivers, that happen to fall inside that buffer that we just created. So we want to go ahead and clip this now to that buffer. Arc toolbox, we can close analysis tools. Remember, we do not want to use the analysis tool here because we're going to be clipping a raster. But first, let's process all 3 of those rasters together. So we have, in this case, let's open up the view shed and look at the attribute table. We'll see where get this out of the way, where the criteria is not visible, it's set the value to 0. And where the criteria is visible, it's set the criteria to 1. So everything I just highlighted is not visible. I'm highlighting now the visible areas that are showing in blue. Sorry, my map is being really slow. So everything that's visible is qualified as value 1. Now what that means is we have 3 different rasters here where the criteria that we're interested in is 1, and the criteria that we're not interested in is 0. Even though it says visible and not visible, that's actually 0 and 1 in your attribute table. So we can go ahead and use a new tool for multiplying these 3 rasters together. And if we multiply them together, only the areas that are all 3 1s will qualify. Everything else will multiply out to 0. So open up our toolbox, scroll down, let's go into, we can do the math tool in Spatial Analyst, or we can use the raster calculator. Let's go ahead and use the raster calculator because we can do this all in one step if we use the raster calculator. If you use the math tools, it's going to do the same functions, but it's going to do them 1 by 1. So you'll see under math, you have a tool called times. You could multiply south by aspect, or by south by view, and that would give you the first multiplication, and then multiply it again by slope less 8 to get the second multiplication. Instead, let's just do this all in raster calculator. So I named mine view is the criteria that meets the view of Tweedy Mountain, times south is the criteria that meets the southern exposure, times slope less 8 is the criteria that meets the low sloping area. So I'm going to call this, first cut, because this is going to cut out everything that doesn't meet all 3 of those criteria. And say okay. Now I have processed, as soon as that comes up, I will have processed through those 3 data, and I can collapse them and take them off of my map, because what I will have when I'm done with this is areas that meet all 3 criteria or do not. And I'm going to process that raster based on the 4th criteria of whether or not it's within 1 mile of the river. So I'm going to use that raster clip to clip out from the new raster I'm creating any areas that fall within 1 mile of the river. So that raster is just processing away right now, running that calculation. Here it comes. Okay, so my first cut, most of my map is gone. See where it says 0? I'm going to make that disappear. Get rid of that, make that a hollow color. I am going to put this, it's blue right now, but I'm going to make this color bright red. Hopefully that's visible to you guys. There's not very much of it. I'll zoom in so you can see that I'm not lying. There is actually some showing up in here. You can see these areas in red are the areas that meet all three of those criteria. Zooming back out. If you're doing this yourself, you can probably see this on your screen, but I know it's really hard for you guys watching this on YouTube. I promise there are multiple areas, little bitty spots in here that are showing up red all through here that meet all three criteria. I'm going to zoom back to the Clark Fork watershed. So now I've got my first cut. That's the one I want to buffer or cut or clip to the buffer of the river. So scrolling back up in ARC Toolbox, I want to go into Data Management Tools because I'm looking for the raster clip. Go into Data Management Tools, Raster, Raster Processing, Clip. So go ahead and open that tool up. Your input raster is your first cut that meets those three criteria. Your output extent is the buffer, US Rivers buffer. And don't forget to check this little box, use input features for clipping geometry, because otherwise it's going to clip to the extent of that buffer, which is the extent of your entire map. We want it to actually clip inside that 1 mile buffer. So we can set our no data value to 0 just to make our lives easier. We've been saying everything that doesn't meet the criteria is 0. So this will help us if we need to do any more mathematical operations. If it doesn't meet the criterion or has no data, it'll be set to 0. You can say OK and let that clip. While that's clipping, I'm going to go ahead and get rid of my first cut because this is going to be my second cut. And I have already now processed through, and I'm also going to remove my US buffers. They're no longer of interest because I will have met those 4 criteria. Everything so far falls within 1 mile of a river, has a south-facing aspect, has a view of Tweedy Mountain, and is on a slope of less than 8 degrees. If it meets those criteria, we've already processed through those. The last thing we want to know, is it more than 10 acres of land? So as soon as this comes up, we'll do that last calculation and we'll take a look at whether or not any of these properties are on 10 acres or more of land. Here it comes. All right, so everything that's 1 meets our criteria. I'll try and blow that up. I'll put that in purple so you can hopefully see that. I see a spot down here. Looks like there's some right here down on the river that met all 4 of our criteria. Now let's see whether any of these parcels are larger than 10 acres. Zoom back out. Just wanted you to see that there are actually parcels in there. There's a little one up here and there's a few throughout the map. We can't really do that calculation to determine whether or not this is 10 acres on a raster because it's all one continuous piece. It's not split into separate pieces. So we want to take this raster and turn it into a shapefile because in a shapefile, we know how to add a column and do calculations in the attribute table. So let's go into ARC Toolbox one more time. We want to collapse everything except conversion tools. Let's go into conversion tools. We're converting from a raster to a polygon because we want to calculate the area of these polygons. So use this raster to polygon. Our input is the first cut raster clip. I didn't rename it, but that's really our second cut. I'm going to call this final locations. Say OK. Now I'm going to, oh, why didn't that work? Let's find out why that didn't work. Simply failed to execute. I'm going to pause you guys while I troubleshoot this. Well, the good news is this thing crashed on me for absolutely no apparent reason, so you guys get to see that this happens to me too. I know this happened to you a lot in class, and I told you over and over again I have no idea what happened. I just ran that same process 2 more times and it processed just fine, so let's try that again. Raster to polygon. Input raster is our first cut clip, really our second cut. The field is the value. We're going to call this final. I suspect maybe I put too many letters in the name. That might be what it was. You have a couple of options here. You can simplify the polygons. What that's going to do is this raster is in 30-meter blocks. It's going to either follow the exact contour around those blocks or those pixels, or you can leave this box simplify polygons checked and it will smooth that out. We don't really need multi-part features, and we can leave the maximum vertices per polygon feature alone because we don't care how many vertices it takes to create that polygon. So let's just go ahead and say okay, and should work this time because it worked the last 2 times. Let's see if we can't get it to process. Here we go. Who knows why? So now we've got the final. I am going to uncheck my first clip. I've got Tweedy Mountain. I'm going to make my final, make that area red so you guys can see it, hopefully. Let's see. I don't see any good spots, but I know there's some in there. So I'm going to open the attribute table and see what I've got. Okay, here we go. We've got, looks like we've got 147 areas that met our criteria. We don't know what the shape area or the shape length, what units they're in necessarily, but they're not in the units we're interested in. I believe they're in meters. So let's go in and add a field. Remember, select on this little icon at the top, your table options, add a field. We want to set this to double because we want the ability to have a large area or a large string of numbers. What did we say? 10 acres. So let's call this acres and say okay. So we've just added a new field for acres, and hopefully you remember how to calculate the geometry. On that column heading acres, right click, go into calculate geometry. Oh, I'm sorry, that's for calculating latitude and longitude. Let's right click and go into field calculator. Nope, I was right the first time. I'm sorry, guys, I hit the wrong thing. Calculate geometry. Yes, I'm about to do this outside of an edit session. I want to calculate the property area, and I want to make sure I set my units to acres. It's calculating in the coordinate system we're working in, UTM zone 12 north, that's fine. Say okay, and it's going to prompt us again that we're outside of an edit session, but that's fine. All right, so now we have a calculation. Scrolling through this list, it looks like there is definitely one larger than 10. Let's see how many there are. Sort that list, scroll down, and here's our cutoff. Would go from 6.58 acres up to 11, and the largest parcel would be 78. So let's highlight those. They showed up on my map down here. I am going to actually switch my selection, and I am going to start an edit session so I can delete those. Start editing. And now I'm going to delete those that did not meet the criteria of being larger than 10 acres. Stop editing. Say yes. Now I have a shapefile or a polygon shapefile that meets all 5 criteria. I've removed anything less than 10 acres. So these 6 parcels meet the criteria of being larger than 10 acres with a south-facing aspect within 1 mile of the river on less than 8 degrees with a view of Tweedy Mountain. Those 6 features, okay? So let's see, let's close that out. It looks like they're all down here. If I zoom to layer, they're all down here, pretty close to each other it looks like. Let's see what this river is, because I believe that was the second question. What river is this? Topmost layer is Clark Fork watershed, so when I used my info tool, it didn't pull up the rivers. I want to set my info tool to select US rivers, oh, not buffer, but US rivers. So now when I use my info tool and click on that, it's going to tell me that this polyline is the Clark Fork River. So all 6 of these parcels that meet our 5 criteria fall along the Clark Fork River. All right. I'm going to clear that selection, and just to waste a little bit of your time, I'm going to undo that and go back out to the entire mosaic. I'm pretty sure I've shown you guys this before, but it's worth looking at again. In the collapse conversion tools, let's go back into Arc Toolbox, into Spatial Analyst Tools. We're going to look at the hillshade. Now, remember, we're limited right now to the extent of the Clark Fork watershed. So when I run this tool, it's not going to hillshade the entire mosaic DEM. But this hillshade tool is really terrific. We've checked the hillshade box on DEMs before, not the same thing. I'm going to run this hillshade tool on the mosaic DEM. Just going to call this hillshade. You can set the azimuth and the altitude if you want. Again, our Z factor should stay 1 because our units are in meters, as is our XY coordinates. So just say okay. When this pops up, I'm going to zoom in on a part of the map that shows the hillshade versus just checking that hillshade DEM. You can see the difference between these two. But this hillshade tool is really phenomenal. It gives you a terrific background image. It does not keep the elevation because it becomes a file that's based on the azimuth and the sun direction. So you get numbers that you can't really do much with as far as processing your data. You need to do that from your DEM, but it gives you a really tremendous graphic for looking at topography and terrain. So that's just processing through, and that should pop up in just a moment. Okay, here we go. So this is the hillshade. I'm going to go into the properties menu on my mosaic DEM and just check that hillshade box so you can see the difference. Remember, that's under symbology. And check that hillshade effect. So it kind of looks like terrain, but nothing like the hillshade. I'm going to zoom in on this. We just look at the hillshade itself. You can see this actually looks like topography. You can see the river floodplain as it comes through the hills through here. And coming over here, looking at the mosaic DEM where we just checked the box, doesn't really look like terrain at all. You can't tell that that's a floodplain. It's just not as good as a graphic. But if you overlay information on top of this hill-shaded DEM and set the transparency, you've got a really dynamic looking map. So just keep in mind, if you want to do anything as far as presenting data with elevation involved, this hillshade tool is really nice. So that's all I have for you guys today. As always, if you have any questions or concerns about today's assignment, give me a shout. Don't forget to answer the 2 homework questions. If you were able to follow along with this, great. If you didn't, I'm really sorry. This is tough on all of us, not being able to do this face-to-face and working in the computer lab. But give me a holler if you have any questions or concerns. All right, thanks guys.